So at the equivalence point, at 25 milliliters added, conceptually what's happened here is that we've taken all of our calcium, it's all reacted with our EDTA, and formed calcium Y2 minus, right? So this has all gone over to here. And then some of this calcium Y2 minus will dissociate, right? At equilibrium, there's some small amount of calcium that's present. Right, so this is as the titration happens, and then at the equivalence point, conceptually what we can think of is a little bit of the calcium will be left behind that won't complex just based on the equilibrium constant. Okay, and so the equilibrium we need to worry about is this equilibrium right here. So we just need to know what's the concentration of calcium Y2 minus. Some of that will dissociate and form our things on our reactants on the left-hand side. And we just use the Kf prime value here, right, which is equal to the concentration of the complex divided by concentration of calcium divided by concentration of EDTA. Okay, so the main thing we need to know is this value right here. How much EDTA do we have? Or how much complex do we have? So what is this concentration? Well, this is just going to be based on how much calcium we started with. That's the amount of EDTA complex that we have. So we take our original concentration, if we had added no volume to our solution, this would be the amount, right? If we had magically kept it equal to this initial volume, this is what it would be. So all we need to do is take dilution into account. So we had initially 50 milliliters. At the equivalence point, we have 75 milliliters of volume because we've added 25. And so that gives us a somewhat lower concentration of 0.0267 molar. Okay, but now that we know this, we can plug this into our Kf prime equation. All right, so let me give myself some space here. Kf prime will be equal to f minus x over x squared. That's just based on the equilibrium expression that I had up here, right? F minus x divided by x squared. And we already calculated the value of Kf prime in a previous video for calcium at pH 10, right? Those are the things we need to know. This is 1.34 times 10 to the 10th. All right, so again, refer to that previous video if you want to remember how to get Kf prime. So then we can plug in our specific value of 0.0267 minus x divided by x squared. We solve for x here. This will give us a quadratic formula, and we'll get 1.4 times 10 to the minus 6 molar. If we plug that into the p calcium formula, negative log base 10, we get a value of 5.85. So this is increased by quite a bit from before the equivalence point, as we'd expect. So in the next video, we'll look at after the equivalence point, how to calculate what's going on with the value of calcium there.